Okay. So, hi everyone. So, good evening all. So, today we will discuss some problems based on uniform plane waves, right? Okay. So, already we have solved some problems based on this uniform plane waves. So, regarding lossless medium, right? So, now in this class we try to solve some problems if the medium is lossy medium. So, if you enter into lossy medium, then in lossy medium we will try to solve some problems here, right? Okay. Okay. So, problems based on lossy medium. So, next is, in this session we are going to solve problems based on lossy medium. Okay. Okay. So I think audio and video everything is clear. So if it is not clear, please let me know through chat box here, right? Okay. Okay. So I hope everything is clear. So write down this problem here. Write down the problem. So the first problem: a lossy dielectric has an intrinsic impedance of 150 at an angle 30 degrees. Okay, ohms. This is the intrinsic impedance value at a particular frequency. At a particular frequency. If at that frequency, the plane wave propagating through the dielectric has the magnetic field component h bar is equal to 20 into e power minus alpha y into sine of omega t minus 1 by 3 into y, ax cap ampere per meter. Okay. So then find E bar, comma, alpha and delta. So delta means skin depth here, right? So determine these parameters, right? Okay. Okay. So let us see what is the question they are asking here is a lossy dielectric has an intrinsic impedance of 150 at an angle 30 degrees ohms, right, at a particular frequency. So this is the intrinsic impedance at a particular frequency. So if at that frequency the plane wave propagating through the dielectric has the magnetic field component h bar is equal to 20 into e power minus alpha y into sine of omega t minus 1 by 3. So here this 1 by 3 is nothing but what? It is nothing but beta. So sine of omega t minus beta y, so where beta value is 1 by 3 radian per meter. Okay. So into ax cap ampere per meter. So that means whenever they have given the expression for the magnetic field, what I have told here, first of all you have to observe in which direction the wave is propagating. So here from this expression we can say the wave is propagating in positive y direction. And what is the component of H field here? What is the component of H field? This is x component. That means H field is pointing in x direction and the wave is propagating in positive y direction. So this is what you have to identify. And this represents what? 20 into e power minus alpha y represents the amplitude of the wave. The amplitude of the wave. So as the wave propagates in positive y direction, so the amplitude is decaying exponentially. Yes or no? As it propagates along y direction, so this y value is going to increase. So alpha is some positive constant, which is nothing but attenuation constant. Okay, so what happens to this amplitude? As y value goes on increases, this amplitude is going to decay. Understood? So here itself they have given the medium is what? The medium is lossy, that is lossy dielectric. So since it is lossy dielectric, the amplitude of the wave is going to decay exponentially, right? Okay, okay. Yeah. So these are the things you have to observe. So they have given this expression and they have given the intrinsic impedance of this lossy medium, and they are asking to determine its corresponding electric field, and also they are asking to determine the attenuation constant of this medium, and also they are asking to determine the skin depth of this medium, right? So these are the things they are asking to determine. Okay, okay. Here. See here, first of all here generally whenever the problems based on lossy medium, whenever problem comes based on lossy medium, generally the students are having some confusion, right? So it is because in lossy medium we can categorize into different types here. So that is, we can say simply lossy dielectric, low lossy dielectric, high lossy dielectric. So for different media the alpha beta values are going to be different. Intrinsic impedance is also going to be different. Understood? Okay. See here, so whenever we enter into lossy medium here, lossy medium means the medium with some finite conductivity or something, right? Okay, okay. Here. So see here, here if they say low lossy dielectric, if they say low lossy dielectric, so this is the terminology they are going to use in the problems. Okay, first of all you have to get familiar with this terminology. So sometimes they will use low lossy dielectric medium, or they will call it as good dielectric medium, and so high lossy dielectric medium, high lossy dielectric medium, or they will call it as good conducting medium, right? Or simply so simply they will call simply lossy dielectric, lossy dielectric. So what is the difference between these terminologies? So you must be familiar with these terminologies here. In general what these terminologies will represent. So if you understand these things, then the problems are going to be very, very simple, right? See here, the nature of the medium is decided by the loss tangent. So loss tangent is nothing but what? Loss tangent will generally represent with tan delta, which is equal to sigma by omega epsilon ratio. Understood? Okay, so it is the ratio of what? It is the ratio of magnitude of conduction current density to magnitude of displacement current density. So if you take the ratio of magnitudes of conduction current density to displacement current density, that is going to give you sigma by omega epsilon. We know that Jc is nothing but sigma into E, Zd is nothing but what? I can write it as j omega epsilon into E. Right. So here E will get cancelled. So the magnitude of sigma is nothing but sigma. The magnitude of j omega epsilon E epsilon is nothing but omega epsilon. So this is the loss tangent here. Right. So depending upon this loss tangent, we can judge whether the medium is behaving as lossy dielectric or low lossy dielectric or high lossy dielectric. Understood? Okay. Okay. So now see here. So if sigma by omega epsilon ratio, is far greater than 1, then the medium we call it as what? Then here, which means sigma by omega epsilon ratio is far greater than 1 means what? Jc is far greater than Zd. So that means in that medium the conduction currents are very much higher when compared to displacement currents. See, if you consider any medium here, so that medium is going to have both conducting nature as well as what? Dielectric nature. So which nature of the medium is dominating? So in order to determine that, we can take the ratio of what? Conduction current density to displacement current density. So if the conduction current density, so the conduction current density is the current density that is associated with the conducting medium, and this displacement current density is the current density that is associated with the dielectric nature of the medium. Understood? So if JC in a medium, if conduction currents are more when compared to displacement currents, then we can say that medium, in that medium, the conducting nature is dominating over dielectric nature. So if the conducting nature is dominating over dielectric nature, so then this sigma by omega epsilon ratio will become far greater than 1. So this medium, we call it as high lossy medium, or we call it as good conducting medium. We call it as good conducting medium. Understood? So JC is very much greater than ZD in this medium. So this medium is going to behave as high lossy medium or good conducting medium, right? Similarly here, if sigma by omega epsilon ratio is far less than 1, okay, so that means in this medium, the ZD, that is the currents that are associated with the dielectric medium, is very much greater than the currents that are associated with the conducting nature of the medium. Understood? So here the displacement currents are dominating over conduction currents, so which means the dielectric nature of the medium is dominating over conducting nature. Okay, so in that case, sigma by omega epsilon ratio will become far less than 1. So in this case, the medium is going to behave as good dielectric medium, or we call it as low lossy medium. We call it as low lossy dielectric or low lossy medium, right? So generally we will name it as high lossy dielectric, right? And here we call this as low lossy dielectric or low lossy medium. Both mean same here, right? Low lossy dielectric or good dielectric medium. Okay, here. So now see here. So here I am simply saying, sigma by omega epsilon ratio must be far greater than 1. Understood? Okay. So in general here, in general for high lossy medium, so in general, if sigma by omega epsilon ratio is greater than or equal to 10, then we are going to treat the medium as a good conducting medium. In general here, this is in general, right? Okay, so in general, if they have not mentioned anything here, then by default in general we are going to consider if sigma by omega epsilon ratio is greater than or equal to 10, then we are going to treat the medium as good conducting medium. So which means here the conduction currents in this medium are greater than 10 times that of what, or greater than or equal to 10 times that of displacement currents. Okay, so in that case we are going to treat the medium as good conducting medium, right? If they have not mentioned anything about this sigma by omega epsilon ratio and all, so then by default we are going to treat this one here. Okay, if suppose in the problem, if they have given like this, so if sigma by omega epsilon ratio is greater than or equal to 50, then treat the medium as a good conducting medium. If suppose in the problem they have given the question like this, if sigma by omega epsilon ratio is greater than or equal to 50, then treat the medium as good conducting medium. If they have given in the question in this manner, then you have to take this condition here. Okay, so if they have not mentioned any condition like this, then by default we consider if sigma by omega epsilon ratio is greater than or equal to 10, then we treat the medium as good conducting medium. See, this is very important here. If you understand these things, then there is no chance that you are going to do the mistake in the problems, right? Okay, so that's why before solving the problem I am explaining all these things, right? Okay, next, so here also for low lossy dielectric, in general by default, if they have not mentioned anything, then by default we will consider if sigma by omega epsilon ratio is less than or equal to 0.1. So in this case, we are going to treat the medium as good dielectric medium, or we call this medium as what? Low lossy dielectric. So this is good conducting medium, or we call this as high lossy dielectric. Okay, so these are the conditions that we are going to take by default if they have not mentioned anything, right? Okay, okay. So now see here. Next, what do you mean by simply if they say lossy dielectric? Understood? So if simply they say lossy dielectric, then it is neither. Then in this case, you have to understand that it is neither good conducting medium nor good dielectric medium. It is neither good conducting medium nor good dielectric medium. So in this case, what is the range of sigma by omega epsilon? So sigma by omega epsilon is going to lie between what? It is going to lie between 0.1 and 10. So if sigma by omega epsilon ratio lies between 0.1 and 10, then we are going to treat the medium as what? Lossy dielectric. Lossy dielectric means generally they mean neither good conducting medium nor good dielectric medium. So in this case, we are going to call the medium as simply lossy dielectric. Understood? Okay, okay. So here, whenever it is neither good conducting nor good dielectric, then in that case they will use the terminology simply lossy dielectric, right? Okay. Or in the problems, if it is low lossy medium, then they will use this terminology, low lossy dielectric or good dielectric medium. If it is high lossy medium, then they are going to use this terminology, high lossy dielectric or good conducting medium. So these are the conditions you have to follow, right? Okay, okay. So I hope this is crystal clear. Okay, okay. So now, so I'm copying this problem here. So now we try to solve this problem, right? So if you want to determine the nature of the medium, then you have to determine sigma by omega epsilon ratio. Okay, so once you determine sigma by omega epsilon ratio, then you can say the nature of the medium. So if you know the nature of the medium, then only you can talk about alpha value, beta value, intrinsic impedance, everything. Understood? Because alpha and beta values are different for this medium, and for this medium also alpha and beta values are different, and for this medium also alpha and beta values are different. Understood? Okay, intrinsic impedance values are also going to be different for different medium, right? So first of all, in the problem you have to understand the nature of the medium. So once you understand that, then only you can apply the formulas in order to calculate, in order to solve the problem, right? Okay, okay, okay. So coming to this problem, so they have given here lossy dielectric. So just now I have told here, so if they have mentioned simply lossy dielectric in general, you have to consider that this is neither good dielectric medium nor good conducting medium. Okay, so first of all they have given here simply lossy dielectric, right? Okay, so lossy dielectric means in general it means neither good conducting medium nor good dielectric medium. Okay, so this is what you have to understand, the first one, right? Okay, so now see here. They have given the intrinsic impedance of the medium as 150 at an angle 30 degrees, right? Okay, so intrinsic impedance of this lossy medium here, So intrinsic impedance is nothing but what? It is the ratio of E to H, right? So this is equal to what? For lossy medium, the expression for intrinsic impedance is square root of j omega mu divided by what? Sigma plus j omega epsilon. So this is the expression for eta lossy, for lossy medium, right? Okay, so this is E by H ratio here, right? So if you observe here, E by H ratio is a complex quantity. So a complex quantity means it is going to have both magnitude as well as phase shift, right? So it is going to have magnitude as well as phase shift. So let us say that is the magnitude of eta lossy I am representing with magnitude of eta lossy, and the phase shift I am representing with phi lossy, right? Okay, so this is nothing but E by H ratio. Okay, here. So what this phase shift will represent here? This phase shift will represent the time phase shift. It represents what? Time phase shift between what? Time phase shift between E and H fields. Time phase shift between E and H fields, right? Okay, so always this phi will represent the time phase shift between E and H fields. See, if you consider lossless medium here, if you consider lossless medium. So what is the intrinsic impedance for lossless medium? Eta is equal to square root of mu by epsilon ohms, right? So what is the condition for lossless medium? Conductivity is equal to 0, epsilon r and mu r values must be what? Are real. Epsilon r and mu r values must be real. So if this satisfies these conditions, then we can treat the medium as lossless medium. So in lossless medium, what is E by H ratio? Is nothing but square root of mu by epsilon. So here mu, epsilon are real quantities. So which means E by H ratio is equal to what? Is equal to the magnitude of this one is simply square root of mu by epsilon. What is the phase shift? Phase shift is nothing but 0 degrees. Since it is a real quantity, the phase shift will be 0 degrees. So which means here in a lossless medium, this represents what? This 0 degrees represents what? The time phase shift between electric field and magnetic field. So if you consider a lossless medium, always the electric field and magnetic field are in time phase. Okay, so are in time phase means what here? They are going to make electric field and magnetic field of a uniform plane wave are going to make a maxima and minima at the same time. Right, so the electric field and magnetic field are going to oscillate with respect to time, yes or no? So this electric field and magnetic field are going to make the maxima and minima at the same time. So which means they are in phase, they are in time phase. Understood? So 0 degrees means they are in time phase. Okay. They are in time phase. Right. Okay. So now see here. So whereas for lossy medium, there exists some time phase shift between E field and H field. So this is what you have to understand between lossless medium and lossy medium. So now here, what is magnitude of eta lossy here? What is magnitude of eta lossy? So the magnitude of eta lossy is equal to what? Is equal to. So what is the magnitude? Tell me. See here, what is the magnitude in the numerator here? I am taking square root. So the numerator magnitude is nothing but omega mu divided by what is the magnitude of this denominator is nothing but square root of sigma square plus omega epsilon square. Right. Okay. So this is the magnitude. So this I can write it as what? I can write it as square root of omega mu divided by. So here omega epsilon whole square I am taking out of this root. So if I take this out of the root, then you are going to get omega epsilon here. Then what is left out here inside the root? So you are going to get here sigma by omega epsilon whole square plus 1. So this is what you are going to get. So here omega will get cancelled. So this one I can represent it as square root of mu by epsilon into what? Into square root of sigma by omega epsilon whole square plus 1. Plus 1. Right. Okay. So in this manner I can represent. So here so the same thing I can represent it as square root of mu by epsilon into 1 divided by sigma by omega epsilon whole square plus 1 whole to the power of what? Here you are having one root and again here you are having another root. So which means whole to the power of 1 by 4. And what is this square root of mu by epsilon here? This square root of mu by epsilon is nothing but what? It represents the intrinsic impedance of a lossless medium. Yes or no? So you can represent, this is nothing but what? This is nothing but I am simply representing eta. So eta is nothing but the intrinsic impedance of lossless medium. So this is nothing but intrinsic impedance. Intrinsic impedance of lossless medium. So square root of mu by epsilon is equivalent to what? Is equivalent to intrinsic impedance of lossless medium. So therefore, the magnitude of eta lossy, we can represent the magnitude of eta lossy in terms of eta, right? So how you can represent? So is equivalent to eta divided by what? Divided by 1 plus sigma by omega epsilon whole square, right? Okay, whole to the power of 1 by 4. So this is the magnitude of eta lossy, right? Okay, okay. So next, what is the phase shift here? What is the phase shift? So you have to determine phi lossy. What is the phase shift? Phi lossy. Okay, so phi lossy is equal to what? Is equal to what? So here I am simply writing eta lossy here. So which is equal to square root of j omega mu divided by sigma plus j omega epsilon, right? Okay, so in the numerator, write down only phase shift here, right? So in the numerator, so here I am taking square root. In the numerator, what is the phase shift? So j means what? J means I can write it as e power j pi by 2. So which means the phase shift is nothing but 90 degrees. Yes or no? So j means 90 degrees. So I can write 90 degrees. Right, okay. So divided by what is the phase shift in the numerator? So in the numerator, the phase shift is nothing but tan inverse of what? Tan inverse of imaginary part divided by real part. So this one I can write it as square root of 90 degrees minus tan inverse of what? Tan inverse of omega epsilon divided by sigma. So this is the phase shift, right? Okay, okay. So therefore phi lossy is equal to what? So if you take the angle out of the root, then what you have to do? You have to divide it by 2. So divide this whole angle by 2. So then what you are going to get? You are going to get 45 degrees minus tan inverse of what? Tan inverse of omega epsilon by sigma divided by 2, right? So this is the expression for phi lossy. So we have represented magnitude of eta lossy, and also we have represented phi lossy, that is the time phase shift between electric field and magnetic field in a lossy dielectric medium, right? Okay. So now see here. Okay, fine. So these are the things that we got. Now here in the problem they have given eta lossy they have given as what here? They have given as a 150 at an angle what? At an angle 30 degrees. 150 at an angle 30 degrees. So this 150 represents what? Represents magnitude of eta lossy, and this 30 degrees will represent what? Will represent phi lossy, right? Okay, okay. So phi lossy. So from here if you compare phi lossy here, what you are going to get? You are going to get 45 degrees minus tan inverse of omega epsilon by sigma divided by 2 is equal to what? Is equal to 30 degrees. Is equal to 30 degrees. Right. Okay. So from here, what you are going to get here? So from here, if you simplify here, so take 30 degrees to this side, you are going to get 15 degrees is equal to tan inverse of omega epsilon by sigma divided by 2. So therefore omega epsilon by sigma, you are going to get what? Tan 30 degrees. So tan 30 value is nothing but 1 by root 3, right? So from here we can determine sigma by omega epsilon ratio here. So sigma by omega epsilon ratio is equal to what? Is equal to root 3. So if you observe here, sigma by omega epsilon ratio, we got root 3. Root 3 means what? Root 3 means how much here? 1.73 or something like that. Yes or no? Okay. So root 3 is nothing but 1.73. So this value is 1.73 here. This value is 1.73. So which means here sigma by omega epsilon ratio is lying between what? 0.1 and 10. Yes or no? It is lying between 0.1 and 10. So that's why this medium is called as what? Lossy dielectric medium. So finally we got the same thing or not? Yes or no? If it is lying between this range, then in general we are going to treat the medium as lossy dielectric. It is neither good conducting nor good dielectric, right? Okay, okay. So they have already given the nature of the medium, that is lossy dielectric. Now here we have proved that one, right? So if the range is between 0.1 and 10, then we can treat the medium as lossy dielectric, which is neither good conducting nor good dielectric, right? Okay, so that's what we have confirmed here, right? Okay, okay. So here, right, see, I am not just solving the problem here. With the help of this problem, I am trying to cover some concepts, right? Okay, okay. So now here, first we try to determine alpha value. First we try to determine alpha value, then we try to write the expression for electric field, and then we try to determine skin depth, right? Okay. So what is alpha value here? How to determine alpha value? So now the medium is lossy dielectric. So for lossy dielectric here, for lossy dielectric medium, we have to determine alpha value. So we know that alpha for lossy dielectric, alpha is equal to what? Omega into square root of mu epsilon divided by 2 into square root of 1 plus sigma by omega epsilon whole square minus 1 whole to the power of 1 by 2, right? Okay, okay. See, it is very easy to remember here. Here omega into square root of mu epsilon by 2. Here you are having square root of 1 plus sigma by omega epsilon whole square minus 1 whole to the power of 1 by 2. Okay, okay. So if you want beta value, so beta. So beta here. So beta is the expression for beta will also looks similar, but only the difference is here in place of minus you have to put plus. Okay. So beta, expression for beta for lossy dielectric medium is omega into square root of mu epsilon by 2 into square root of 1 plus sigma by omega epsilon whole square plus 1 whole to the power of what? Whole to the power of 1 by 2. Right. Okay. 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 So these are the expressions here. These are the expressions for alpha and beta. Now see here. Now we want to determine alpha value. We know beta value, right? We know beta value. We know beta value, and we know sigma by omega epsilon value also. We know sigma by omega epsilon value also, right? We know beta value. We know sigma by omega epsilon value. So now we want to determine alpha value. So what I am going to do here is, if I take the ratio of alpha to beta here, if I take the ratio of alpha to beta, then I am going to get only the known quantities. Yes or no? So this term will get cancelled. So then what is going to left out? So you are going to have 1 plus sigma by omega epsilon whole square minus 1 divided by what? Divided by square root of 1 plus sigma by omega epsilon whole square plus 1 whole to the power of what? Whole to the power of 1 by 2. And we know sigma by omega epsilon value, right? So what is sigma by omega epsilon ratio here? So sigma by omega epsilon ratio, we got it as what? We got it as root 3. Yes or no? Okay. Omega epsilon by sigma we got it as 1 by root 3, which means sigma by omega epsilon value is root 3. So now here just substitute here in place of sigma by omega epsilon, just substitute root 3. Just substitute root 3. Okay. So what you are going to get if you substitute root 3? So 1 plus root 3 whole square is nothing but 1 plus 3, that is root 4. Root 4 is 2. So 2 minus 1 will be 1. So in the numerator you are going to get 1 divided by what? In the denominator what you are going to get? 1 plus root 3 whole square, that is 1 plus 3, that is root 4. So root 4 is 2. 2 plus 1 is 3. So 1 by 3 whole to the power of 1 by 2. Right. So alpha, and what is beta value? What is beta value they have given? Beta value they have given it as what? 1 by 3. I think beta value will be 1 by 3. Right. So beta value they have given as 1 by 3 here. Right. Okay. So beta value is 1 by 3. Okay, beta value you can substitute later. So therefore alpha is equal to what? Alpha is equal to 1 by root 3 into beta, which is equal to what? 1 by 3 root 3. So since beta value is equal to what? 1 by 3 radian per meter. Okay. So since beta value is 1 by 3, so alpha will become what? Beta by root 3. So that is 1 by 3 root 3. What are the units of alpha here? So therefore alpha is equal to 1 by 3 root 3 Nepper per meter. Nepper per meter. Right. Okay. Okay. So if they ask to determine alpha in terms of dB per meter, always remember, there is no need to always convert from Nepper to dB and all those things here. So if you remember this formula, then always you can easily convert, from Neppers to dB. So if they ask alpha in dB per meter, then always use this relation. So that is always 1 Nepper here, 1 Nepper you can write it as 8.68 dB. Always you can write 1 Nepper as what? 8.68 dB. So 1 dB is equal to what? 1 divided by 8.68 Nepper. Right? Okay. Yeah. So if they ask to determine in terms of dB, then this is the relation you can use. Right? So by replacing 1 Nepper with 8.68 dB, you are going to get what? In terms of dB per meter. Okay. Yeah. So this is alpha value. So now next they have asked to determine skin depth. Yes or no? They have asked to determine skin depth. Right. So what do you mean by skin depth here? What do you mean by skin depth? So skin depth is nothing but what? It is the depth to which an electromagnetic wave penetrates into a medium before its amplitude decays to 1 by E times of its initial amplitude. See, that means see here. So here if I consider this as some lossy medium here, I am considering this as some lossy medium, right? Okay. Lossy medium. So let us say this is z direction. And let us say this is 0. Okay. Here the wave is propagating in which direction here? Y direction. No? So let us consider this as y. Let us consider this direction as y. Right. Okay. So the amplitude of the electric field, let us say the amplitude of the electric field in a lossy medium is going to decay exponentially. Yes or no? So generally the amplitude of the electric field will be like what? E naught into e power minus alpha into y. So this is the amplitude of the electric field in a lossy medium. It is going to decay exponentially. Right. Okay. So at y equal to 0, it is going to have its peak amplitude. So that is nothing but E naught. So now as the EM wave propagates into this medium, what will happen? Its amplitude is going to decay exponentially. Like this. Right. Okay. So what do you mean by skin depth here? So skin depth means the depth to which an EM wave can penetrate into a medium before its amplitude decays to what? Decays to 1 by E times of its initial amplitude. So that means here the amplitude is decaying as what? E naught into e power minus alpha into y. Right. Minus alpha into y. Okay, so let us say at this location, at this point, the amplitude is equivalent to what? 1 by E times of E naught. Let us say here the amplitude has become 1 by E times of E naught. So this distance here, this distance we call it as what? We call it as skin depth. So what is this distance here? What is this distance? Tell me. So at this location, exactly at this location, the amplitude is becoming 1 by E times of E naught. So when this will become 1 by E times of E naught here, when it will become 1 by E times of E naught. So whenever y is equal to what? Y is equal to 1 by alpha. Understood? So that means this distance is equal to what? Y is equal to 1 by alpha meters. So whenever the wave penetrates into a medium by a distance of 1 by alpha meters, then the amplitude is going to become what? Is going to become 1 by E times of its initial amplitude. So this depth to which an EM wave has penetrated before its amplitude decays to 1 by E times of E naught is called as what? Is called as skin depth. So this distance we call it as what? We call it as skin depth here. Right. So skin depth generally will represent with delta, which is equal to what? Which is equal to 1 by alpha meters. So this is the actual formula for skin depth. Understood? Delta is equal to what? 1 by alpha. You can define the skin depth for any medium here. So that is delta is equal to 1 by alpha. Right. And this alpha value is going to vary from one medium to another medium. See, if I consider a lossless medium here. So in a lossless medium, we know that the amplitude will never decay. Yes or no? So if I consider a lossless medium, the amplitude is not going to decay, which means in that case the skin depth will be infinity. Yes or no? So we know that in a lossless medium alpha is equal to 0, right? So if I consider lossless medium, so in lossless medium the alpha is equal to what? Alpha is equal to 0, which means what? Delta is equal to 1 by 0, which is nothing but what? Infinity. Yes or no? This is the skin depth in case of lossless medium. Now if I consider high lossy dielectric, then delta is equal to what? High lossy dielectric or good conducting medium. So in this case delta is equal to 1 by alpha. So now here you have to substitute the value of alpha for good conducting medium. So for alpha value in a good conducting medium is equal to square root of omega mu sigma divided by 2r. Right. So you have to substitute this alpha value. So if you consider low loss dielectric or good dielectric medium, then in this case delta, the skin depth, whatever may be the medium, in general the skin depth is equal to 1 by alpha, and you have to substitute the value of alpha corresponding to that medium. Okay, so for good dielectric medium alpha is equal to sigma by 2 into eta, where this eta is nothing but square root of mu by epsilon, right? Okay, so this is the expression for alpha in case of what? Low loss dielectric. So you have to substitute this value here in order to determine the skin depth. Understood? Okay, so always remember that the skin depth is equivalent to 1 by alpha. For lossless medium it is infinity. For high lossy dielectric medium it is 1 by alpha, where alpha is equal to square root of omega mu sigma by 2, and for low loss dielectric delta is equal to 1 by alpha, and for low loss dielectric alpha is equal to sigma by 2 into eta. Understood? Okay, yeah. So first of all you have to identify the nature of the medium, then accordingly you have to write the expression for delta. Right. Suppose in the problems they have not given any clue in order to determine the nature of the medium. And they are simply asking to determine the skin depth. Okay. Then in that case, if they have not mentioned anything, so note, you can make a note here. So if they have not mentioned anything, see, if you are clear with these things here, then there will be no confusion while solving the problems. Okay. So if they have not given any clue to determine what? To determine nature of the medium, then by default you have to consider the skin depth. Delta for what? For good conducting medium. So if they have not mentioned anything about the medium, so they have not given any clue to determine the nature of the medium, and if they simply talking about the skin depth, then by default you have to consider the skin depth for what? The skin depth for good conducting medium or high lossy dielectric, right? Okay. So Anand Seemakurti, hi Anand. Okay, after a long time I am seeing you, right? Okay, I think it has been almost 2 to 3 months, right? Okay, so after a long time again I am seeing you in chat box, right? Okay, it's good to see you here, right? Okay. Right, so these things you have to keep in mind. Okay. Right. Next, if you observe here, here the medium is what? Here in the problem they have given the medium as lossy dielectric. Yes or no? Okay. So in the medium they have given the medium as what? The medium as lossy dielectric, right? So in lossy dielectric, they are asking to determine skin depth. So skin depth is equal to what? 1 by alpha. Already we have determined alpha value here. Yes or no? So what is alpha value? 1 by 3 root 3, right? Okay. So alpha is equal to 1 by 3 root 3. So 1 divided by 3 root 3. So which is equal to what? Which is equal to 3 root 3 meters. So this is the skin depth. This is the skin depth for this problem, right? Okay. Okay, yeah. So for lossy dielectric here, so I have not represented here for lossy dielectric. I have represented for lossless, high lossy dielectric, low lossy dielectric. So if the medium is lossy dielectric, right? Okay, here write down. If the medium is simply lossy dielectric, simply they have given as lossy dielectric. So in this case also, delta is equal to 1 by alpha, where alpha is equal to what? Alpha is equal to omega into square root of mu epsilon by 2 into square root of 1 plus sigma by omega epsilon whole square minus 1 whole to the power of 1 by 2. So this is the expression you have to use for alpha, right? Okay. Okay, yeah. Okay. So just by seeing this, you can understand that determining the nature of the medium is very, very important, right? Because depending upon the nature of the medium, all these values are going to change, right? Okay. Okay, yeah. So next, what they have asked here, we have determined alpha, we have determined delta, and they have asked to determine electric field, right? Okay. So they have given the expression for magnetic field, and they are asking to determine the expression for magnetic field. Okay. So they have given the expression for H field and asking to determine the expression for electric field, right? Okay. So we know already in the previous session I have told if they have given magnetic field, how to determine its corresponding electric field. I have told already, right? So how to determine electric field here? So electric field E bar is equal to what? Is equal to eta into H bar. So here eta is nothing but what? Eta lossy here, eta lossy, right? So this is for lossy dielectric. Remember that this is for lossy dielectric. Okay, so eta lossy H bar cross what? Cross AP cap. So this AP cap represents the direction of wave propagation. Here the wave is propagating in which direction? Positive Y direction. So which means here AP cap is nothing but what? AY cap, right? Okay, yeah. So now, and here H bar is equal to 20 into e power minus alpha y into sine of omega t minus 1 by 3 y ax cap. See, eta lossy, what I have told, eta lossy is nothing but E by H ratio, so which is a complex quantity, so it is going to have both magnitude as well as what? As well as phase shift. Understood? Okay. Okay, yeah. So now here this is magnitude of eta lossy and this is the time phase shift between electric field and magnetic field. So whenever you are writing the expression for electric field here, so expression for electric field, so here electric field E is equal to what? E is equal to H into what? H into magnitude of eta lossy into this is phi lossy, right? So what you have to do here is just multiply the amplitude of H field with what? With eta lossy, and this phase shift has to be added in the expression of what? In the expression of here, this is nothing but phase or not? Yes or no? So here in the phase term, you have to add this phase shift, right? So that's how you have to write the expression for electric field, right? Okay. Okay, yeah. So now see here, so E bar is equal to, so what is magnitude of eta lossy we got? What is magnitude of eta lossy? What we got here? Magnitude of eta lossy. Okay, we have not determined. So magnitude of eta lossy is equal to what? Is equal to eta. So eta is nothing but eta naught into square root of mu r divided by epsilon r divided by what? Divided by 1 plus sigma by omega epsilon ratio, what we got? Root 3. Yes or no? So root 3 whole square whole to the power of what? 1 by 4. So this is equal to, right? Okay. Sorry, they have already given na. Sorry, there is no need to determine all these things. Already they have given na eta value 150 at an angle 30 degrees. Yes or no? Okay. Okay. Sorry. So here they have given already the value of eta lossy. Yes or no? So they have given it as 150 at an angle what? At an angle 30 degrees. So 150 is the magnitude of eta lossy, right? Okay. So multiply the magnitude of eta lossy with the amplitude of H field. So what you are going to get? 150 into 20. Yes or no? So 150 into 20, how much you are going to get? You are going to get 3000, right? So this is nothing but 150 into 20 here, right? Okay. Okay. So multiplied by what? Multiplied by e power minus alpha y into sine of omega t minus 1 by 3 into y. What is the time phase shift between electric field and magnetic field here? Is nothing but 30 degrees. So in the phase term, just add that phase shift here. So what you are having? 30 degrees. So just add here plus 30 degrees, or you can add in place of 30 degrees you can write pi by 6, right? Okay, right, or pi by 6 radians. You can write either in terms of degrees or radians. Okay, so this is going to become the expression for electric field. And here what is alpha value? Alpha value what we got here? 1 by 3 root 3. Yes or no? 1 by 3 root 3, right? Okay. Okay, so I think everything is correct. 1 by 3 root 3, right? Okay. Okay, so next, that's it. Okay. Okay, so we can write this is the expression here. This is the expression we can write. So 3000 into e power minus 1 by 3 root 3 y into sine of omega t minus 1 by 3 y plus 30 degrees. So this is how you have to represent the electric field, right? So multiply the magnitude of eta lossy with what? With the amplitude of H field, and phase shift you have to add in the phase term here, right? Okay, so this is how you have to determine. So I hope everything is crystal clear here. I hope everything is crystal clear. So if you are having any doubts, you can ask me here. So otherwise we will proceed to next problem. Right? Okay. 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 So next, write down next problem. So next problem here. A plane wave propagating through a medium. A plane wave propagating through a medium with epsilon r equal to 8, mu r equal to 2, has E bar, electric field E bar is equal to 0.5 into e power minus z by 3 into sine of 10 to the power of 8t minus beta z ax cap. into beta z Ax cap volt per meter, okay. So then determine A, loss tangent, B, beta value, C, wave impedance. See, wave impedance or intrinsic impedance, both mean same here, okay. Wave impedance means you have to determine eta. Next, wave velocity. So wave velocity means you have to determine phase velocity here, right. So next, finally you have to determine the expression for H field, okay. Here, see, I have taken this problem from Sadiku. Here, okay. See, the same problem here, the same type of problem they have given in gate. The only change they have given wrongly here, they have copied each and everything in the same manner. They have given epsilon r value, they have given mu r value, they have given the same expression for electric field. But here in the data they have given sigma, is equal to 0. They have included this one also, right. See, they have mentioned in the problem, in gate problem, I am saying in gate problem, what they have given is, they have given the same thing here. They have mentioned same thing, each and everything is same, right, okay. So here they have mentioned epsilon r is equal to 8 and mu r is equal to 2, and they have given sigma equal to 0, and they have given this expression. So here the confusion will start. Why means, here epsilon r value is 8, which means epsilon is a real quantity, yes or no. Mu r is equal to 2, which means mu value is real quantity. Mu equal to what? Mu naught into mu r. So mu r is real means mu is also real quantity. So epsilon r is real means epsilon is also real quantity. Understood? Okay. So if epsilon r, mu r values are real and sigma is equal to 0, then this is the condition here. This is the condition. So if epsilon r and mu r values are real and sigma is equal to 0, then the medium is going to behave as what? Then the medium is going to behave as lossless medium. Right, okay, lossless medium here. But in a lossless medium, we know that whenever the wave is propagating, its amplitude is not going to decay exponentially. We know that one, right? But once they have given this data, here they have given 0.5 into e power minus z by 3 as it is. They have given 0.5 into e power minus z by 3 as it is. Right. So this is wrong or not? Because they have given the condition for lossless medium. So just by seeing this, we can say that the medium is lossless medium. So in a lossless medium, the amplitude should not decay exponentially. But they have mentioned in this manner 0.5 into e power minus z by 3. Right. So which is what? Which is absolutely wrong. Yes or no? And here in this problem, they have asked sigma equal to 0 means they have given this data and they have asked to determine beta value. Right. Okay. So since they have given epsilon r value, mu r value real and sigma is equal to 0, we have to assume that the medium must be what? The medium must be lossless. So they have given this amplitude wrongly. So you have to remove this one and you have to consider 0.5 into sine of 10 power 80 minus beta z, and this is going to behave as lossless medium according to this condition. So just replay, they are asking beta. So beta is equal to what? Omega by, I can write it as omega by c into square root of mu r epsilon r. Yes or no? How you are getting this relation here? So omega by beta, I can write it as what? I can write it as phase velocity, which is equal to what? Which is equal to c by square root of mu r epsilon r. So this is for what? This is for lossless medium. So here beta is equal to what? If you take beta that side, you are going to get beta is equal to omega by c into square root of mu r epsilon r. So here they have given mu r value, they have given epsilon r value, and here they have given omega value, and c value is nothing but 3 into 10 to the power of 10. If you substitute all those values, you can happily get beta value. Understood? Okay. Okay. Here. So they have given wrongly here. They have given wrongly this problem here. So if they have given sigma equal to 0 here, they should not mention this e power minus z by 3. So this is wrong, right? Okay. So sometimes it will happen here. Sometimes it will happen in the gate questions, in the gate and IES questions sometimes it will happen, right? Okay, okay. But if you check Sadiku book, they have not given this sigma equal to 0. They have not given this sigma is equal to 0, right? So which means sigma is not equal to 0. How you can understand that sigma is not equal to 0? Because here they have given only epsilon r value and mu r value, right? They have not mentioned anything about what? They have not mentioned anything about sigma. So in that case, you cannot judge whether the medium is lossy medium or lossless medium. Understood? So here, according to this expression, by looking at this expression, we can judge here. So they have given this expression. Now they have given the amplitude as 0.5 into e power minus z by 3, which means the amplitude is decaying here. So the amplitude is decaying means the medium is behaving as what? The medium is behaving as lossy medium. So which means here, since epsilon r and mu r are real quantities, now sigma should not be what? Is not equal to 0. So then it is going to behave as what? Then it is going to behave as lossy medium. So if all the conditions here, if all the conditions, that is epsilon r, mu r value are real quantities and sigma is equal to 0, if all these conditions are satisfied, then only it is going to behave as lossless medium. If any of these conditions are not satisfied, then it is going to behave as lossy medium. Okay, so already they have given this epsilon r value, mu r value are real quantities. So, and the amplitude is decaying exponentially, which means we have to consider, we have to understand that this medium is behaving as lossy medium, which means sigma is not equal to 0. Right? Okay, so this is the conclusion we have to make. See, in the recent IES exam also here, in the recent IES exam also, so they have given the electric field E bar is equal to 2 into e power minus alpha z into sine of omega t minus beta, something they have given here. So here they have asked to determine alpha value and beta value, right? And they have given the conductivity of the medium as 3 Siemens per meter, something, some values, epsilon r value, like that they have mentioned. Understood? So this problem also exactly copy and paste from Sadiku book. Okay, so recently, day before yesterday, last Sunday, IAS exam has conducted now. Okay, so in that exam they have given this question. So we got alpha value is equal to 61.4 number per meter, beta value is also 61.4 something, the same value we got. I have solved this problem also. Okay, in the previous session I have solved this problem also. Right, you can check that. So this problem also copy and paste from Sadiku book here. Same problem as it is they have given in IES exam. Right, okay. Not only this year, I have observed many questions. Which are given in Sadiku book. They have given directly in IES exam and GATE exam also, just with some modifications. Right, okay, okay. So that's why we always prefer to follow Sadiku, right? See, from that book you cannot understand the concepts and all those things. It is very difficult directly to understand the problems just by studying that book, right? So you have to get the concepts from us, from faculty, right? So within less time you can get the concepts from us because we have already done that work. Right, so you have to learn the concepts from us and try to practice the problems in those standard textbooks like Sadiku and all. Right, okay, we can expect maximum with the slight changes, we can expect the same type of problems in the exams also. Okay, okay, yeah. Right, okay. So this is the problem here, this is the actual problem. Here sigma is not equal to 0, that's what you have to understand. Okay, so now here they are asking determine loss tangent and determine beta value and then determine wave impedance and then determine wave velocity and determine H field. So these are the things they are asking, right? Okay, so first we try to determine loss tangent. Okay, so loss tangent. See, this is very, very important here, loss tangent. Determining the loss tangent is very, very important. It is going to tell you about the nature of the medium. Once you know that, then only you can proceed the problem. right? Okay, so loss tangent is nothing but sigma by omega epsilon ratio. So this is what you have to determine. But in the problem, if you observe, they have not mentioned anything about sigma, right? So here they have given omega value, and here they have given epsilon r value. So that means epsilon is equal to epsilon naught into epsilon r. We know epsilon naught value, epsilon r value also they have given. So we can determine epsilon value and we can determine omega value, right? But we don't know sigma value. We don't know here sigma value. So in that case, how you can determine this is sigma by omega epsilon ratio? Tell me. We don't know this sigma value. Right? Okay. What we know? We know omega value and we know what? We know epsilon value. So then in that case, how we can determine the sigma value? Okay. Okay. Yeah. So now see here. Right. Okay. So here, since they have not mentioned anything about this sigma by sigma value, okay, so what we will do here is we are going to assume the medium as lossy dielectric. We simply assume the medium as what? We assume the medium as lossy dielectric, right? Okay. Okay. Lossy dielectric, and for lossy dielectric here, wait. Okay, here see from here what we can understand here, 0.5 into e power minus z by 3. So this is just like what? 0.5 into what? E power minus alpha into z. And here alpha value is equal to what? Alpha value is equal to 1 by 3. Okay. Okay. So that's what we know. So here we know that alpha value they have given it as 1 by 3 Nepper per meter. Right? Okay. Okay. So now see here. Alpha is equal to 1 by 3, right? Okay, so alpha is equal to 1 by 3 and we are considering the medium as lossy dielectric. So lossy dielectric means it is neither what? It is neither low lossy dielectric nor what? Nor high lossy dielectric. Okay, since they have not mentioned whether it is low lossy dielectric or high lossy dielectric, so that's why we are going to assume it as simply lossy dielectric, which means it is neither low lossy nor high lossy. Okay, so if it is low lossy or high lossy, they will definitely mention specifically about that here. Okay, since they have not mentioned anything, so we'll assume that the medium as lossy dielectric, which means neither low lossy nor high lossy. So in that case, what is the expression for alpha here? What is the expression for alpha? So alpha is equal to what? Alpha is equal to omega into square root of mu epsilon by 2 into square root of 1 plus sigma by omega epsilon whole square minus 1 whole to the power of 1 by 2, right? Okay, so see here, from this expression we know alpha value, right? And we know mu values and epsilon values, and we know omega value also, right? So from this expression, okay, omega value also we know, right? Okay, so from this expression we can determine what? We can determine sigma by omega epsilon ratio. So if you determine sigma by omega epsilon ratio, then that is nothing but what? Loss tangent. So from this expression we can happily determine sigma by omega epsilon ratio. So see here, alpha value is nothing but 1 by 3. So this is equal to, so here omega into square root of mu epsilon. So how I can write this one here? Omega into square root of mu epsilon divided by root 2. So this I can write it as omega by c into root 2 into what? Square root of mu r epsilon r. So in this manner can I write here? Tell me. See, c means what? C means 1 by square root of mu naught epsilon naught. So if you take this to the numerator, you are going to get square root of mu naught mu r epsilon r, which is nothing but what? Square root of mu epsilon. Okay, so the same expression here, the same expression I can write it as omega by c. See, square root of mu epsilon means what? Square root of mu epsilon is nothing but what? 1 by phase velocity. Yes or no? Or you can write in this manner. If you are having any confusion, I can say in this manner. See here. Right. So omega, this I can write it as omega divided by root 2 into 1 by square root of mu naught epsilon naught into what? Into square root of, or you can write mu naught epsilon naught into mu r epsilon r. So in this manner I can write it. Yes or no? So I have written root mu by mu epsilon as a omega divided by 1 divided by square root of mu epsilon, where mu epsilon is nothing but mu naught epsilon naught mu r epsilon r. So this is equal to, I can write it as omega by root 2 into 1 by square root of mu naught epsilon naught. 1 by square root of mu naught epsilon naught is nothing but what? Is nothing but c. Next, what is left out? 1 by square root of mu r epsilon r. So if you take this to the numerator, I can write it as mu r epsilon r. Right. Now it is very easy for us to determine this value. So omega value they have given as what? Omega value they have given as 10 power 8 divided by root 2 into c value is nothing but 3 into 10 power 8 into square root of mu r value they have given as what? Mu r value they have given as 2, epsilon r value is 8. So mu r into epsilon r, that is 8 into 2, that is 16. Okay. Okay, here. So here 10 power 8 will get cancelled. So square root of 16 is nothing but 4. So you are getting here 4 by 3 root 2 here. 4 by 3 root 2. Yes or no? So this is the value of omega into square root of mu epsilon divided by root 2. So this value is 4 by 3 root 2. Okay. Okay, here. So here alpha value is 1 by 3, which is equal to omega square root of mu by square root of mu epsilon by 2 is how much here? 4 by 3 root 2. 4 by 3 root 2 into what? Square root of 1 plus sigma by omega epsilon whole square minus 1 whole to the power of 1 by 2. So now here 3 will get cancelled. So 4 by root 2 here. 4 by root 2, what you are going to get? 2 root 2. Okay, so now take this 2 root 2 to this side, 1 by 2 root 2 and square on both sides here. What you are going to get? 1 by 2 root 2 whole square is equal to what? Square root of 1 plus sigma by omega epsilon whole square minus 1. So if you square on both sides, this root will get cancelled, this 1 by 2 will get cancelled. So then you are going to get square root of 1 plus sigma by omega epsilon whole square minus 1. Okay. Okay, so I have taken this 2 root 2 to this side, so 1 by 2 root 2 I am going to get, then after that I have squared on both sides. So then you are going to get this expression. So 1 by 2 root 2 whole square is nothing but what? 1 by 8. I am taking this 1 to this side, so you are going to get square root of 1 plus sigma by omega epsilon whole square. Okay, so here what you are going to get? 1 by 8 plus 1 is nothing but 9 by 8. 9 by 8. Okay, so now again squaring on both sides here, what you are going to get? 9 by 8 whole square is equal to what? Is equal to 1 plus sigma by omega epsilon whole square. So therefore sigma by omega epsilon whole square is equal to what? So 9 by 8 whole square minus 1, so that is 81 divided by 64 minus 1. So if you want sigma by omega epsilon ratio, then you have to take the root of this value. Okay, so if you do this, what you are going to get? Tell me what you are going to get. So 81 divided by 64 minus 1, so square root of answer, so that is 0.515 here. So therefore sigma by omega epsilon is equal to what? 0.515. Okay, see, there are no units for sigma by omega epsilon ratio. It is the ratio of what? It is the ratio of conduction current density to displacement current density. Understood? Both are having the same units, numerator and denominator both are having the same units, and hence the units will get cancelled. So sigma by omega epsilon ratio is not going to have any units, right? So sigma by omega epsilon ratio is equal to what? 0.515. So that's what you are going to get. So this is the value of loss tangent here. So this is nothing but loss tangent. So we have determined loss tangent value, right? Okay. So once we have determined loss tangent value, then we can determine what? Beta value. So they ask you to determine what? Beta value. So beta for lossy dielectric is nothing but what? Omega into square root of mu epsilon by 2 into what? Square root of 1 plus sigma by omega epsilon whole square plus 1 whole to the power of 1 by 2. Okay, we have already determined this value here, omega into square root of mu epsilon by 2. So what is this value we got here? We got this value as 4 by 3 root 2. Yes or no? So omega into square root of mu epsilon by root 2 is nothing but what? Is nothing but 4 by 3 root 2. Okay. So into square root of 1 plus sigma by omega epsilon ratio, we got 0.515. So 0.515 whole square plus what? Plus 1 whole to the power of 1 by 2. So just calculate this value here. So then you are going to get beta value, right? Okay. Okay. So 1 plus 0.515 square under root, okay, plus 1 again under root, okay, into 4 divided by 3 root 2. Okay, so you are going to get 1.374 radian per meter. So this is beta value. So beta value you will get it as what? 1.374 radian per meter. Okay. So next what they are asking? So we have determined loss tangent sigma by omega epsilon ratio, we have determined beta value, and now they are asking to determine wave impedance, that is intrinsic impedance here. Okay, so you have to determine the intrinsic impedance. So intrinsic impedance for which medium? This is lossy medium. Yes or no? So this is equivalent to what? This is equivalent to square root of j omega mu divided by sigma plus j omega epsilon, sigma by j omega epsilon, right? So already we know the magnitude of eta lossy. What is the magnitude of eta lossy here? The magnitude of eta lossy is nothing but what? Is nothing but, I can write it as eta divided by 1 plus sigma by omega epsilon whole square whole to the power of what? Whole to the power of 1 by 4. In the previous problem we have derived this one here. Okay, so eta lossy magnitude is nothing but what? Eta divided by 1 plus sigma by omega epsilon whole square whole to the power of 1 by 4, where this eta is nothing but what? Is nothing but square root of mu by epsilon. Okay, so in the problem here, you can represent here eta lossy, right? So generally in books they don't mention the subscripts and all. So in order to make you understand, I am writing these subscripts, right? Okay. So eta is nothing but square root of mu by epsilon. So which is nothing but what? This I can write it as square root of mu naught by epsilon naught into what? Square root of mu r by epsilon r. So square root of mu naught by epsilon naught is nothing but intrinsic impedance of free space, which is nothing but 120 pi. And what is the value of square root of mu r by epsilon r? So mu r value they have given as what? Mu r value they have given as 2 and epsilon r value is 8. Mu r is 2, epsilon r is 8. So 2 1s, 2 4s. So 1 by square root of 4. So that is nothing but 1 by 2. So you are going to get here 60 pi. Okay. So this eta value you are going to get 60 pi r. Right. And we know this sigma by omega epsilon value. What is this sigma by omega epsilon value? Is nothing but 0.515. Okay, so just substitute all this, then you are going to get the magnitude of eta lossy. So that is equal to 60 pi divided by 1 plus 0.515 whole square whole to the power of 1 by 4. Okay, So determine this magnitude here. I am determining magnitude here, right? So 1 plus 0.515 square whole to the power of 1 divided by 4. Okay, 60 pi divided by answer. So you are going to get 177.73 here. You can write 177.73. So this is the magnitude. This is the magnitude. And what is a phase shift here? What is phase shift? So phase shift I am representing with phi lossy, right? So which is equal to what? Which is equal to, we got 45 degrees minus tan inverse of what? Tan inverse of omega epsilon by sigma divided by 2, right? So this is the expression for phi lossy, right? Already in the previous problem we have derived these things here. Okay, okay. So now see here what you are going to get here, 45 degrees minus tan inverse of what? Tan inverse of omega epsilon by sigma. So we know that sigma by omega epsilon is equal to 0.515. So omega epsilon by sigma will be approximately 2 point or something like that. Yes or no? Okay. So 1 divided by 0.515 is nothing but 1.94, right? So this is equal to 1.9417 omega epsilon by sigma value. Okay, so substitute omega epsilon by sigma value, that is 1.9417. So divided by what? Divided by 2. Okay, so if you calculate this value, what you are going to get? Tell me. So shift tan inverse of 1.9417, okay, divided by 2. Okay, 45 minus answer. So you will get 13.62 here, 13.624 degrees. Okay, okay. So this is phi lossy, right? So therefore intrinsic impedance, of the medium is equal to magnitude of eta lossy at an angle what? At an angle phi lossy, which is equal to what? Magnitude, how much we got? Magnitude 177.73. So we got 177.73 at an angle what? At an angle 13.62 degrees. Okay, okay. So this is the answer we got for eta lossy. This is the intrinsic impedance of the medium. Okay, okay. So next, so we have determined the wave impedance or intrinsic impedance, both mean same. Then they are asking wave velocity. So what is wave velocity here? What is wave velocity? We know that we can determine the wave velocity. The wave velocity means phase velocity. So the phase velocity of the wave is equal to what? Is equal to, it is the ratio of omega by beta. Yes or no? So omega is nothing but 10 power 8 and beta value we have already determined here. So what is beta value? I think 1.37 or something. Yes. So 1.374. Okay. And omega value is 10 power 8. Right. Omega value is 10 power 8. So substitute those values here. So 10 power 8 divided by 1.374. So 1 divided by 1.374 is 0.727 into 10 to the power of 8 meters per second, or you can write it as 7.27 into 10 to the power of 7 meters per second. Okay, so this is the answer for phase velocity, right? Okay, so next what they have given, so they are asked to determine H field. They are asked to determine H field. So can you determine H field here? Can you determine H field? They have given electric field and they are asking to determine H field. Okay, okay. So see here. So we are very much familiar, if they have given electric field, how to determine magnetic field. Okay, okay. Right. and here we got eta lossy is equal to 177.73 at an angle 13.62, right, 13.62 degrees. So this is nothing but phi lossy, and this is nothing but magnitude of eta lossy, right. So remember these things. Okay. So now they have given electric field and asking to determine magnetic field. So we know that if you want to determine H field, so H field is equal to AP cap cross what? Cross E bar divided by what? Divided by eta lossy, right. Okay. So here AP cap represents the direction of wave propagation. So here the wave is propagating in which direction? Positive Z direction. So that means AP cap is nothing but AZ cap. So write down here AZ cap cross E bar is nothing but 0.5 into e power minus Z by 3 into sine of the phase of the wave is nothing but 10 power 8 t minus beta Z into what? into AX cap, right. Okay. So now here we are dividing this with what? Eta lossy. So it is going to have magnitude as well as phase shift. So whenever you are writing the magnitude, so just write down the magnitude here, magnitude of eta lossy. But what you have to do? Phase shift. What you have to do? The phase shift. Here you are getting eta in the denominator. Understood? So which means you have to subtract the phase. You have to subtract this phase shift here. Yes or no? So this is the phase here. This is the overall phase. See, if you are multiplying with eta lossy, see, whenever you are determining E bar, so what you are going to get? Eta into what? Eta into H bar cross what? Cross AP cap. Understood? So let us say this is for eta lossy. So in this case, what we have done here in the previous problem, what we have done? We have multiplied the magnitude of eta lossy with the amplitude of H field. Then what we have done? The phase shift of this eta lossy we have added in the phase term. Yes or no? But here in this expression we are getting this eta lossy in the denominator. So which means we have to divide this whole thing with the magnitude of eta lossy, and in the phase term you have to subtract this phase shift. Yes or no? Here you are getting in terms of multiplication, here you are getting here in the division. So that's why you have to simply subtract the phase shift here. Okay. So what you have to write here? You are going to get minus what? Minus phi lossy. So I hope you have understood this point here. So this is nothing but minus phi lossy. Okay. So minus phi lossy, right. Okay. So whereas if you want to write the expression for electric field, here you are multiplying with eta. So what you have to do? You are multiplying the amplitude of H field with the magnitude of eta lossy, and you have to add the phase shift to the phase term. But here you are dividing with eta lossy, so you have to subtract the phase shift. Within this phase. Understood? Okay. Deepak, hi Deepak. Right. Okay. So just these small things if you understand, then there is no way that you are going to do the mistake in the problem, right. Okay. Right. Okay. So now what you are going to get? Substitute these values here. So eta lossy is nothing but 177.73, right. And here beta value is nothing but 1.374, and here phi lossy is nothing but 13.62 degrees. So just substitute all this. So therefore H bar is equal to 0.5 divided by 177.73 into e power minus Z by 3 into sine of what? Sine of 10 power 8t minus beta value is 1.374. So 1.374 into Z minus phi lossy is how much here? 13.62 degrees. Understood? Okay. Next, you have to write the direction. So here you are having AZ cap and here you are having AX cap. So you are doing the cross product here. Here you are doing the cross product, right? Okay. So AZ cap cross AX cap is nothing but what? AZ cap cross AX cap is nothing but AY cap. So this is AY cap, right? So this is the H field here. So what is this 0.5 divided by 177.73? So here you are going to get 2.813 into 10 power minus 3 here, into 10 power minus 3. So here this is ampere per meter. Okay. So here you are going to get 10 power minus 3 into e power minus z by 3 into sine of 10 power 8t minus 1.374 z minus 13.62 degrees AY cap. Okay. Okay. So if you remove this 10 power minus 3, I can write in terms of milliampere per meter. Okay. So if I remove this 10 power minus 3, okay, then I can write the units as what? I can write the units as milliampere per meter. Milliampere per meter. Okay. Okay. So 2.813 into e power minus z by 3 into e power minus z by 3 into sine of 10 power 8t minus 1.374 z minus 13.62 degrees AY cap milliampere per meter. So this is the way to determine the H field. So Ruturaj Puranik, sir, I have just started with this playlist and I am here to say that nobody can teach EMT like you do. You are taking so much effort for us. Thanks a lot, sir. I will catch up with you soon. Thanks. So thank you, dear. Thank you. Thank you, Puranak. Thank you very much. Right. Okay. Okay. Right. So this is the expression for H field here. So in this manner you have to write the H field. Okay. Okay. So just you have to take care whenever you are dividing with eta. Whenever you are dividing with eta, so what you have to do? You have to subtract here the phase shift. So that's what you have to determine. That's what you have to take care. Right. Okay. So whenever you are multiplying with eta, so that is whenever you are determining E bar, so E bar is equal to eta into what? Eta into H bar cross AP cap, right? Okay. So here whenever you are determining like this, then you are multiplying with eta, so which means you have to multiply the magnitude of eta with the amplitude of H field and you have to add the phase shift in the H field expression. Understood? Okay. Okay. So only these things you have to take care of. So remaining each and everything is you can easily write here. So generally where the students will do mistake is while writing this eta, right? So that's why I am specifying these things, right? So with this here, with this I am winding up the session for today, right? Okay. So tomorrow we will take up some more problems here. See, I am taking one problem in such a way that in that problem I am trying to cover most of the concepts, right? Okay. And also I am telling you how to solve that problem in a simple manner, right? Okay. Okay. So these things you have to understand. Okay. So with this here, with this I am winding up the session for today. So I hope you have understood each and everything. So if you are having any doubts, you can ask me. So otherwise we will wind up the session, right? Okay. Okay. So let us see if you are having any doubts. If you are having any doubts, you can ask me. I will wait for 1 minute. So if you are not having any doubts, then we can wind up the session. Naveen Sunkari, sir, when will take class on oblique incidence? I will take here. I will take. So I cannot specify the exact date. Now we are following topic by topic now. Just now I have started this uniform plane waves. So we have covered lossless medium and we have covered now lossy medium. So in lossy medium we'll try to solve some more problems. So then later I will cover pointing theorem and all. So after that I will go for maybe oblique incidence and normal incidence topics, or I am in dilemma whether to take transmission lines or this oblique incidence or normal incidence topic. Okay, so I will decide that later, but as of now I am dealing with lossy medium, right? Okay, so maybe within a few days I will start this oblique incidence, normal incidence topics also, right? Okay. Okay, so with this I am winding up the session. So I hope no doubts, right? Okay. So tomorrow we'll meet exactly. The EMT class will be at 7:30 p.m. Right? We'll meet tomorrow exactly at 7:30 p.m. Okay. And also tomorrow at around 4:30 p.m. here. Around 4:30 p.m. I am taking some non-tech session. I am taking non-tech session, that is how to what are the do's and don'ts during gate preparation. Okay. So on this I am taking the non-tech session tomorrow at 4:30 p.m. So approximately I will take half an hour or 45 minutes like that. Okay. So it is completely non-tech session. So here I am going to discuss what are the do's and don'ts during gate preparation. So how you have to prepare while preparing for gate, what are the things that you have to take care of. So that thing I am going to discuss in the non-tech session at 4:30 p.m. So after this at 7:30 p.m. we are going to start our EMT session, right? Okay. So attend tomorrow. We are having 2 sessions here. So attend to both the sessions. Okay. So with this I am winding up the session for today, right? So tomorrow we'll meet exactly at the same timing. So until then, take care. Bye bye.